Hello, calculus students. Today is Friday, May 4th, otherwise known as May the 4th be with you. The secret word for today in honor of Star Wars Day is Jedi. That's Jedi. Today's topic is going to be all the derivative rules. And when I say all the derivative rules, I mean all of them. So I am not going to spend time going over things like the power rule, the product rule, the quotient rule, the chain rule. My assumption is that you have these things under control before you're watching this video. If you need some additional support, if you are a calculus student and you have your calculus survival guide, go to Unit 3, find the formulas that are on page 3 in section 3. These are the ones that you have to have memorized in order to just be ready for anything and everything that comes your way. You don't want to derive any of these things in the middle of the test. You don't have time. Now on page 4, there are some other derivative formulas. These are a little less known. They appear more often on the BC exam than on the Calculus AB exam. But if you are really hungry for a 5, you want to watch this video. You want to spend some time with the formulas on page 4, especially the derivatives of inverse functions on the bottom of page 4. Make some flashcards, study with a partner, quiz yourself on a regular basis for a few minutes every night. You have to have these under control. This needs to be the kind of questions, or these need to be the kinds of questions and the skills you have ready to go all of the time. What I'm going to do, though, to push your thinking a little bit more is work with you on what you might do in the middle of the test if you, let's say you have a brain fart. You did not study the fact that the derivative of the secant of x is equal to the secant of x times tangent of x, and you need to come up with that in the moment. Well, here's what I know. I want to find the derivative of secant of x, but if I don't know that the derivative of secant is secant of x times tangent of x, what I can do is I can rewrite the secant as 1 over the cosine of x. That's a trig relationship, not a calculus relationship, a trig relationship. Secant is 1 over cosine. And then I can use, because this is a fraction, I can use the quotient rule. The quotient rule says low, so cosine of x, d high, that's the derivative of the numerator, minus high, times d low, derivative of the denominator, well, that's negative sine of x, all over the cosine of x, the whole thing squared. Low d high minus high d low, low low. Cleaning this up a little bit, well, cosine of x times 0 is going to be 0. Negative 1 times negative sine of x is sine of x, over cosine of x, the whole thing squared. That's great. That's the derivative. That might not actually be helpful for you, though, because that's not going to show up as one of the answer choices. What you can do from here is you can use a little bit of algebra and a little bit of trig. Sine of x over cosine of x squared is the same as sine of x over cosine of x times 1 over cosine. Sine over cosine, you know from trigonometry, is tangent of x. 1 over cosine, we also know from trigonometry, is secant of x. So this shows me that the derivative of secant of x is equal to tangent of x times secant of x. You can derive this just like we did, or you can spend a little bit of time, memorize this relationship. Make a flashcard, quiz yourself, go from there. Okay. Let's look at another one. Derivative of cotangent of x. How are we going to find the derivative of cotangent of x? Well, if we were in class, I would say turn to your partner, have a strategy conversation. What are you going to do? And I hope eventually somebody would say, well, what do I know? I know that the cotangent is the cosine of x over the sine of x. If I want to take the derivative of cosine of x over sine of x, you've got it. Quotient rule. So low d high, derivative of the cosine is negative sine of x minus the high. D low, derivative of sine of x is cosine of x all over low sine of x squared. Well, let's see. Sine of x times negative sine of x is negative sine squared. Cosine of x times cosine of x is cosine squared. Sine of x times sine of x is sine squared. That's good. It's great. Free response? Leave it. No reason to do anything else. But if you're on the multiple choice, this won't be the answer choice. It won't be one of your options. What they're going to do to hide this from you, negative sine squared of x, negative cosine squared of x, I'm going to factor out a negative 1, leaving me sine squared of x plus cosine of x. In the denominator, sine squared of x. And where I want to draw your attention is right here to the sine squared of x plus cosine squared of x. This is known as the Pythagorean identity. Right? Pythagoras from like Pythagorean theorem. Pythagorean identity says that anytime you have sine squared of x plus the cosine squared of x, that's going to be equal to 1. So I can replace this guy here with 1, and I've got negative 1 over sine squared of x. Again, that's great. Probably not a multiple choice answer. I'm going to rewrite this as negative 1 over sine of x times 1 over sine of x. The negative of 1 over sine of x is negative cosecant of x. 1 over sine of x is cosecant. Negative cosecant times cosecant is negative cosecant squared of x. Okay, pretty good. These are two that I would expect are going to show up on the Calculus AB exam. This next one, however, probably not so much. This one is going to be a push, not impossible, just a little bit of a push. It can be shown that the derivative of a to the x, where a is a constant, is a to the x times the natural log of a, as long as a is greater than 0. And you might be thinking to yourself, well, gosh, that looks an awful lot like what we do with the derivative of e to the x. Well, what's the derivative of e to the x? The derivative of e to the x is just e to the x. Why do I need this special formula? And would this special formula work when I take the derivative of e to the x? Well, let's see. According to this formula, the derivative of a constant to a power is your constant raised to that power times the natural log of your constant. Well, that's not what we normally write now, is it? What we normally would say is it's just e to the x. How are these two things the same? Well, the natural log of e is just 1, so you get e to the x times 1, which is e to the x. Now, what I want to do is I want to take a little bit of time and show you how this idea gets expanded. So let's say I'm working with something like y equals 2 to the x. Not e to the x, but a different base. Well, we don't really know how to take the derivative of 2 to the x yet, but there are some things we could do. We can take the natural log of both sides. If y equals 2 to the x, then the natural log preserves that equality. Using powers of the log, I can bring that properties of logs, I can bring the exponent down in front, and now take the derivative with respect to x. The derivative of the natural log of y is 1 over y times dy dx. Think chain rule. The derivative of x times the natural log of 2 is 1 times the natural log of 2. If I multiply both sides by y, we get that dy dx equals y times the natural log of 2. And you might think, well, but what's your answer? What's your derivative? Well, what was y? Y was 2 to the x. So dy dx is 2 to the x times the natural log of 2. We went through, we started with y equals 2 to the x, which is what I wanted to find the derivative of. We didn't know how to do that. We took the natural log on both sides. That allowed us to use properties of logs. We then took the derivative with respect to x, which is y over here. When we said derivative of natural log of y, we said 1 over y times dy dx equals 1 times natural log of 2. Solving for dy dx, replacing y with 2 to the x, that's our derivative. Now, there was nothing special at all about the choice of 2 to the x as the base. So what if the base is a, where a is constant? Well, then we're going to have natural log of y equals the natural log of a to the x. I'm going to bring that power down. Natural log of y equals x times natural log of a. Take the derivative. A is constant, so natural log of a is a constant. Y is a to the x, so now we have a to the x times the natural log of a. Done. Not too bad. We're not going to do the fourth one, derivative of arctangent of x. I think most of my students at this point, we've talked about it enough, we've seen it enough, you just know it's 1 over 1 plus x squared, and the way that you would go about deriving it is probably not going to be super helpful at this point. So in just a bit, we're going to continue with the derivatives. If I didn't mention it, I'm on page 21 of the Special Topics handout. And where we're going to go next is we're going to flip past the multiple choice. We're going to look on page 25 when I come back in just a moment. All right, friends, I'm back. You need to take a little break there. So this question comes from the Master Math Mentor, Stu Schwartz, who has brought us so many really good questions. The functions f and g are differentiable for all real numbers x. Differentiable just means derivatives exist. The table below gives values of the function and their first derivatives at selected values of x, with a being constant. A is constant. Want to make sure I keep that in mind. So for x, I've got 1, 2, 3, and 4. Then they give me information about f of x at those points, f prime of x, g of x, and g prime. This is a really typical kind of question I'd expect to see on the AP exam. Part A, if h of x equals sine, now how we're going to read this, sine of f of x, write an equation of the line tangent to h at the point where x equals 1. Well, we do stuff like this all the time. Equation of tangent line means that we need a point and we need a slope. The point we know has an x value of 1. To get the y value, we're going to evaluate h of 1. Well, h of 1 is sine of f of 1. What do we know? We're going to go to the table, find x equals 1, go over to where f is. F of 1 is 3 pi over 4. To find the sine of 3 pi over 4, you can think about your unit circle. Pi over 4 is 45 degrees. 3 times that is 135. So there we are. This angle here is pi over 4, which means that this side across is square root of 2 over 2, and the adjacent side is negative square root of 2 over 2. So sine of 3 pi over 4 has to be square root of 2 over 2. So now we know the x coordinate and we know the corresponding y coordinate. The slope is h prime of 1, and I make a big deal about this with my students. When you want to find the value of the derivative at a point, you have to first find the derivative as a function. The function is sine of f of x. So your derivative is going to be cosine of f of x, and then because of the chain rule, times f prime of x. To find h prime of 1, we need the cosine of f of 1 times f prime of 1. F of 1 we discovered earlier is 3 pi over 4. So I need the cosine of 3 pi over 4 times f prime of 1. The cosine of 3 pi over 4 is negative square root of 2 over 2. F prime of 1, go back to your table. X is equal to 1. F prime of 1 is square root of 2. If you want to multiply these together, that's fine. Negative square root of 2 over 2 times square root of 2 over 1 is going to be negative, well, square root of 2 times square root of 2 is square root of 4. 2 over 2, negative 1 is the slope. Pull it together, your tangent line is going to be L of x is equal to negative 1, x minus 1, plus the square root of 2 over 2. There you go. That's part A. So since this isn't a College Board question, it's really hard to say where you would earn points. I am confident, though, that finding the derivative would get you 1 point, possibly even 2, because you had to use the chain rule. Finding the value of the derivative at 1, whether you leave it in this form or you simplify, would be 1 point, and probably writing the equation of the tangent line would be the last point. I'd guess maybe 4 points, but again, since this isn't a College Board question, you can't really know for sure. All right, let's keep going. In part B, we're told that r of x is 1 over the square root of g of 2x, and they want me to find r prime of 2. That means I have to first find the derivative of r, and then evaluate at 2. Now, I bet a lot of students are going to say, hey, this is a fraction, let's use the chain rule. I'm sorry, that's a fraction, let's use the quotient rule. That's great, that works. If you see it that way, go for it. But I've also seen a lot of students be really successful, and that's how I want to model this one. 1 over the square root of g of 2x is the same as saying g of 2x to the negative 1/2 power. Think about that for a second. You've got the square root of g of 2x, that means g of 2x to the 1/2 power. Because that's in the denominator, that means the exponent should be negative. Now when I go and I find the derivative, r prime, I've got g of 2x to the negative 1/2 power. Chain rule, you're going to bring that negative 1/2 down. G of 2x to the 1 less power times the derivative of g of 2x. And just for right now, I'm going to write it this way. Power rule said bring the power down in front, reduce 1 from the power. Chain rule says multiply by the derivative of what's on the inside. Well, let's finish that off. Negative 1/2 times g of 2x to the negative 3/2. The derivative of g of 2x, that's right, I said it, g of means we need the chain rule, so g prime of 2x times 2. This is your derivative function. To find r prime of 2, everywhere there's an x, you're going to plug in 2. Negative 1/2, g of 4 to the negative 3/2 times g prime of 2 times 2, that's 4, times 2, well, let's see, negative 1/2, what's g of 4? I find x equals 4. G of 4 is 9. So negative 1/2, 9 to the 3/2, times g prime of 4 times 2. Oh, sorry about that. Let's keep going. 9 to the negative 3/2 power means take the square root of 9, that's 3, raise it to the 3rd power, that's 27, but that negative exponent means that what I actually have is 1 over 27. So negative 1/2 times 1 over 27. times g prime of 4, go to your table, x equals 4, g prime of 4 is 3 times 2. If I multiply this out, well, I can reduce the 2's. And if I do that right, I think we get negative 1 over 9. That's part B. Not too bad, just more skills, more practice with the derivative. Okay, let's see what we've got coming up in part C. Part C, you're going to have to put your thinking cap on, and I'm going to have to do my folding thing. Okay, so here we go. Love my little folding trick. All right, there we go. Part C. This is going to make you stop and think. Find the values of A, or find the value or values of A, if the tangent lines to f of g of x and g of f of x are perpendicular at x equals 3. What? Tangent lines. Okay, I know what to do there. I've got two different functions, and they're saying that the tangent lines are perpendicular. You might remember from algebra, from geometry, if two lines are perpendicular, their slopes are negative reciprocals. So if I have two lines, M1 and M2, or two slopes, M1 and M2, if the lines are perpendicular, the slope of the first is the negative reciprocal of the slope of the second. Okay, well, let's come back to this. We've got f of g of x. We've got g of f of x. What I need to find is the slope of the tangent line for each function at x equals 3, which means we're going to take the derivative. Well, what's the derivative of f of g of x? Chain rule says f prime of g of x times g prime. The slope at x equals 3 means everywhere I see an x, plug in 3. We've got f prime of g of 3 times g prime of 3. Go to your table. G of 3 is 4. So now I've got f prime of 4. G prime of 3 is a half. Now I need to find f prime of 4 times a half. Here's x equals 4. F prime is 2a squared. So I've got 2a squared times a half, which is a squared. That is the derivative of f of g of x at x equals 3. Now we're going to find the derivative of g of f of x. Well, chain rule says g prime of f of x times f prime. When we evaluated x equals 3, that means plug in 3. G prime of f of 3 times f prime of 3. Let me scoot that up. F of 3 is 5. G prime of 5 times f prime of 3. G prime of 5. No. G prime of f of x times f prime of x at x equals 3. F of 3. Oh, thank goodness. F of 3 is not 5. Duh. F of 3 is 1. Sorry about that. Okay, let me back it up. Jackie, apologies again. G prime of 1 times f prime of 3. The mistake I made is I went to the table and I found that f of 3 is 5 and 5 is nowhere in my table. Okay, let's finish it up. G prime of 1 is 1 over a. F prime of 3, f prime of 3, that's equal to 5. So we get 5 over a. Now, stop and think for a second. What you have here is the slope of the tangent line to f of g of x at 3. And down here, you've got the slope of the tangent line to g of f of x at x equals 3. These are not equal to each other because the lines are perpendicular. The slope of the first one is the negative reciprocal of the slope of the next one. That means that a squared is equal to negative 1 divided by 5 over a is the same as negative a over 5. To solve for a, I can multiply both sides by a. 5a squared equals negative a. I can add a to both sides. 5a squared plus a is equal to 0. Factor out the a. Set each factor equal to 0. And so a is 0 or a is negative 1 over 5. My friends, that's it for that one. Again, I'm not going to worry about where the points are coming from. That doesn't matter nearly as much. Okay, we've got time for just one more problem, so here it comes. I'm now on the top of page 26. Okay, this is our last question. Let me clean up my workspace a little bit, and then I can post this video and get on with the rest of the night. Okay, top of page 26. Create a new differentiable, consider a new differentiable function k of x, which satisfies the conditions that k of 2 is 0, k prime of 2 is equal to 1/2. For j of x equals arc cosine of kx, find j prime of 2. Using this information, determine the behavior of j at x equals 2. Whoa! J is the arc cosine of k of x, and they want me to determine the behavior of j at x equals 2. The way that we can determine the behavior of a function is we're going to look at the derivative. Remember, if the derivative is positive, then your function is increasing at that point. If your derivative is negative, your function is going to be decreasing at that point. If the derivative is 0, then you've got a horizontal tangent line. That's the kind of stuff we're talking about here. Okay. Well, let's find the derivative. Derivative of arc cosine. If you need to take a moment and go look that up, feel free. Of course, in the middle of an exam, you're not able to do that. The derivative formula for arc cosine of x is negative 1 over square root of 1 minus x squared. That's not what I need here. I need the derivative of the arc cosine of another function. This is going to be the chain rule. J prime is the negative 1 over square root 1 minus k of x squared times the derivative, which is k prime. That's your derivative. I want to know the behavior, so I need to know the derivative at 2. So we get negative 1 square root 1 minus k of 2 squared times k prime of 2. What did they tell us? They told us that k of 2 is 0. So we've got negative 1 over square root 1 minus 0 squared. K prime of 2, they told us, is 1/2. If I clean this up, you're going to get negative 1/2. All we really care about is that the derivative is negative. What's your conclusion? The derivative of j at 2 is negative, and so I'd say this. Since j prime of 2 is negative, the graph of j of x, tell me what it's doing. The graph of j of x is decreasing. Now tell me when the graph is decreasing. The graph is decreasing at x equals 2. My guess for how points are going to be awarded is probably 2 points for the derivative. 1 if you even just have this form. The other point for having the using the chain rule. Probably not a point for the plug-in, but a point for getting to this place over here where you know the derivative is negative, and then one more point for your conclusion. This is not what I would think to be an impossible problem. I think the fact that you're dealing with the derivative of the arc cosine makes it a little tough, but once you know that, everything else should fall into place really nicely. Well, friends, that is the end of this video. Have a great night. Happy studying.